Linus, this is the most expensive fan in our office. More expensive than all of these combined, and this one's $250.
What the? Are you me right now? No. It moves like no air.
Okay.
Is this honestly? Okay. This is without a doubt the strangest, most expensive, most niche fan that we have ever seen. And I cannot wait to tell you guys how it works after I tell you how to make money on YouTube.
PDQ, take patch management off your plate by automating the snot out of it. PDQ can keep your machines patched and up to date automatically, giving you time to do more important things like watching Linus Tech Tips. Start your free trial at pdq.com/Linus.
Hey Linus, are you okay to be shocked for science?
Damn it! Okay, damn it! I mean, what choice do I have at this point?
I mean, a lot of people fantasize about physically harming their bosses. So.
To understand the principles behind this strange little fan, first, we need to have a little chat about piezoelectrics. A piezoelectric refers to something that is able to turn mechanical energy into electrical energy or vice versa. Piezoelectrics are all around us, from the quartz crystal that keeps time in your watch to the stylus of a record player, or even the switch of this lighter. The way this guy works is there's a spring that compresses when I push down the switch. Then when it hits a certain point, all that spring energy gets released. A small hammer hits this piezoelectric crystal, resulting in and this can work the opposite way and turn electrical energy into mechanical movement. So inside this fan, there are two piezoelectric ceramics that are sandwiched together. One that contracts with positive voltage and the other that contracts with negative voltage. That means when you plug it into the wall, the AC power will make it start to vibrate. Let's do that. How does this have no specs on it? Is that even legal?
It's fine.
Well, what voltage does it run at?
120.
This is 120. These vibrations are very small, which is why the very fact that I'm holding it dampens them out so much that you can barely even see that it's moving. But if you place it in something more rigid or even hold it a little tighter, that's because the blade had to be very carefully tuned so that the natural frequency matched the input frequency, and it has to be matched within a couple of hertz. That's why we need this power supply instead of just running straight off the mains.
Yeah.
Your mains power can be kind of all over the place. To illustrate the importance of this, think of the blade here kind of like this washer on a string. If I just randomly move my hand around, the washer barely moves. We're not blowing any air with this, but if I time it correctly, I can get the washer going pretty good. That's because I'm matching my input to the natural frequency of this system. Same principle here. So the size and weight of this blade has to be carefully tuned or it will barely move, which actually means that this one here won't work in Europe because here in North America, our wall power is at 60 hertz and in Europe it's 50. They actually tried tuning the blade to somewhere in between, but it has to be within about 1 or 2 hertz for it to work. It's hula hoop in elementary gym class all over again.
Really?
I have no rhythm, sir.
But your waist.
What are you saying?
What?
All right, where do you want this masking tape?
Just right on the end somewhere. Doesn't really matter.
Just like a big old whack of it, or like?
I don't know. I haven't tried this yet.
Oh, I see.
Maybe it'll work way better.
Okay. I think that what I'm trying to do is increase the surface area.
All that you're trying to do is just knock it out of natural frequency.
Oh, I see. Well, all right. There. Will that be enough?
No.
It still seems to work pretty good.
That's way less than before, though.
I want to touch it. Can I touch it?
You can touch it.
Eee!
All right, we have a job to do. Yep, 0.55.
Let's go back. Just that tiny little bit of masking tape and then try it again. Whoa, Nelly.
Now it's almost an inch. That's double with just that tiny piece of tape.
So we're basically paying for some master piezo craftsman.
No, we're paying for they only make a couple of them a year. That was later in the script, but like, you know now.
Before we go any further, this is more than just a party trick, and blowing air by waving a piece of fiberglass around has a couple of big advantages. First of all, there are no wear surfaces. I mean, Sure, this fan has high quality bearings that'll let it spin for a while, but eventually it's going to seize up. Noctua rates their fans at about 150,000 hours of operation, or about 17 years. That's not bad. But the folks over at piezo.com had one of these babies nailed to the wall in 1982 that ran non-stop until 2008, with the only required maintenance being occasional dusting. Oh, yeah, and actually it was still fine after those 26 years. They just moved offices and figured the poor thing had had enough. Another key advantage is dust management. If you were in a clean room, for instance, and you had a fan like this running, it would shed tiny trace amounts of oil and dust into the surrounding environment. This, on the other hand, sheds absolutely nothing. An even bigger benefit, though, is power consumption. This tiny 40mm fan is rated for 0.5 watts, which, when you factor in the inefficiency of converting AC to DC power, lands us at about 1 watt. That's about as low as you can get with a traditional fan. Our piezoelectric fan, on the other hand, gets most of its motion from hitting that natural frequency, making it incredibly power efficient. I mean, think back to our washer again. What's more efficient, going like this or going like this? This one is rated for 100 to 200 milliwatts, but unfortunately we clearly don't have the resolution to measure that. So we're gonna move on to our next station, which is testing its performance compared to this boy. Can you see this okay, or do we need a black background here?
I can see it, but black background might be better.
You know what? I have an idea. How about this LTT Store backpack? We're gonna have 4 waves of availability in the coming weeks, so make sure you get your order in so that you are in the queue. Oh, wow. It really goes, doesn't it? I didn't think I was gonna get that much airflow out of it. You can really see a night and day difference between it being slightly behind the fiberglass reed and then right next to it. So that's clearly where the intake is, like right along the sides here. That's so bizarre. The air current is so much greater than what it feels like. Like, it looks like it's freaking blowing these things. I can't even feel it. In my notes, it says it has essentially 0 static pressure and needs free air around it to bring in. It's not axial like a normal fan. But this still, even though I'm reading that off a teleprompter, I don't get it. How can something blow this much air and yet I cannot feel it at all? Like, there's no pressure. Like, I can, but barely.
Okay, well, let's just compare it to this.
Sure.
A 40mm.
It's gonna get absolutely annihilated. Noctua would never let us down. Yeah, my cost performance analysis is that this is probably better for most things. Don't need the lab to tell me that. No, you're good, you're good. Man, I could get into incense if it's always like playing around with cooling fans. Next up, time to cool a computer with it. Technically the Steam Deck is a computer, and it is one that we already managed excellent results with using a 40mm cooling fan. So, will our piezoelectric fan be a suitable replacement? I suspect no, but we're gonna give it a shot anyway. Alex, how the hecking, okay, this is pretty cool.
You might want to turn it off first.
No, it seems fine.
I'm turning it off.
Yeah, that's probably for the best.
You don't need to undo it that much. I had it undone so it would be like perfect. You could have just slotted it right in.
Oh, Valve Steam Deck, now with 3,000% more vibration.
How much does that fan make the bomb go up?
That's pretty good though. I mean, it's fairly lightweight, you know, bud?
Low power.
Yeah, low power, which is really important in a mobile device.
You get to plug it into the wall.
Oh yeah, no, we couldn't run this off of the Steam Deck battery because it's AC.
You can get lower voltage versions, that would probably work.
Oh God. Well, here's part of it. No, I'm not even. What the?
Do you know how to hold a Steam Deck?
I know how to Steam Deck.
Yeah, maybe this would help us.
Oh my God, Alex, you knew you were gonna do this, didn't you? Oh my God.
Okay, let's not do that.
You just clamped onto the screen of a Steam Deck. Do you know how few working Steam Decks there are in the wild?
None work better than this one.
So don't ruin it.
This is the best cooling solution we've ever had on this Steam Deck.
It's the worst one.
So low power.
It's not the key button.
While I tool around and do maternal to heat this boy up, Alex is going to explain more about the construction of our piezoelectric fan. Our goal is less than 63 degrees, which is what we got with our 40mm Noctua.
It's basically just a circuit board. Fiberglass, you have your 2 piezoelectric ceramics, which are just thin little things. Instead of putting copper in your circuit board, you put those in, smack it together. Whole thing,
Sorry, I didn't mean to interrupt.
if they made a lot of them, could be very, very cheap.
Yeah, I was going to say, so what's the issue? It's the precision manufacturing, or?
No, just they make very few of them. They actually mentioned that they really like it when videos like this come out because a bunch of people buy them just for tooling around with them like us.
Apparently there are a few on the space station, which is pretty cool, because while on Earth, convection happens naturally. When air gets hot, it gets less dense, it rises, letting cool air replace it. In zero gravity though, that hot air just stays there around whatever is producing heat. So a piezoelectric fan is a super low power way to simulate convection. In talking to Mide though, they were like, yeah, we have some fans deployed for zero gravity, but those volumes are so low it can hardly allow you to run a business. Fair enough. Quite a few then are also used for sensors, like temperature sensors, smoke detectors, chemical detectors, and so on and so forth. By gently moving air across a sensor, you can significantly reduce how long it takes for something to get detected. And once again, the super low power draw means that a sensing unit can be battery powered. One other benefit this fan has over a traditional fan is the start and stop time. It is blowing air within milliseconds of being powered on and stops almost instantly when power is removed. And one situation this can be very useful is for lasers. This is the chiller that keeps our laser tube cooled. But even though it keeps our laser tube within a couple of degrees, on etching jobs, a couple of degrees can be enough to noticeably change the darkness of the etch. In some highly advanced lasers then, they'll have both heaters and these fans to control the temperature to within 1/100ths of a degree. And finally, they do get used to cool electronics, just not in this application. Now, we actually maxed out at 50 degrees Celsius on our CPU. I have no idea how that works. Maybe we're utilizing more of the heatsink?
Well, but also like our other fan.
It was off the whole time.
Oh, damn.
Yeah, like it's actually working pretty well. Normally not in an application like this though. Normally in a sealed container just to create a tiny bit of airflow for the poor low power chip that's going to the deep sea or somewhere equally unpleasant for electronics. You know what's never unpleasant though? My segue to our sponsor.
Vessi. Vessi proves that waterproof shoes don't have to be ugly or uncomfortable. Thanks to their Dymatex technology, you can keep those toes dry while remaining sleek, snug, and stylish. I love sleek toes. Need even more comfort and breathability? The Everyday Move line has added padding at the midsole and a looser knit to keep up with your busy, active lifestyle. Do you hate tying laces? Yes. Tired of chasing the rabbit around the tree and down the hole? Well, fear not, because Vessi's Everyday Move shoe comes with handy pull tabs for easy slip-on action and are made 100% creature-free, so you can be walking on those fluffy clouds of your clear conscience all day long. And when Vessi says everyday move, they mean it. Hot, cold, wet, dry. Stay comfortable in any weather. Walk through a bog and then walk to the bar. Just think of all the freedom you could have with these new shoes. So treat those feet of yours with Vessi Everyday Move shoes and save $25 with offer code LinusTechTips at vessi.com/LinusTechTips.
If you guys enjoyed this video and you're looking for an equally exotic cooling solution, go check out our Vortex cooler video. It's mind-blowing. I still have no idea what happened there.